Add and subtract rational expressions. In order to add or subtract, with fractions, you have to have a like denominator, meaning the bottom of the fraction has to be identical. So if we start with a denominator that is the same, then all we have to do is combine the numerators. So if we have a over c plus b over c, we can combine them into the single fraction where we have a plus b all over a single c. Same would apply for subtraction. So they give us a couple of examples here. If we have 3x over 5x squared plus 7 over 5x squared, we can combine it into the single fraction 3x plus 7 over 5x squared. For the second one, it's subtraction, same denominator, so the denominator will stay x plus 1, and the numerator, we can combine it, 9x cubed minus x squared. You can factor it if you want, since they both have an x squared. You can take out the x squared and make it x squared times 9x minus 1, but it's not vital that you do that because we still can't simplify anything. We don't have any like terms or things that can divide out, So common factors, that's what I mean. We don't have any common factors. This factor is 9x minus 1, this one is x plus 1, and this one is x squared. So either of these two would be acceptable. Most of our focus in this lesson, though, is going to be on what we do when we don't have common denominators. So if we are adding or subtracting with unlike denominators, our first step is to get a common denominator. Once we have the common denominator, then we just go ahead and combine the numerators. So if we had a over c plus b over d, our common denominator would be the product of c, d, or their least common multiple. So we take the first fraction times d over d and get ad over cd. For this one, we'd multiply by c over c, we get bc over cd. We combine the numerators and we have ad plus bc all over cd. Same thing for subtraction, find the common denominator, multiply each fraction by whatever you need to get the denominators to be the same. Denominator stays the same and you just combine the numerators. You can always find a common denominator by multiplying the denominators. However, if you use the least common multiple to find the least common denominator, you'll have less simplifying to do. That means less factoring. So if you want to avoid the factoring and attempting to simplify, then always try and find your least common multiple, or least common denominator. So the least common multiple, let's remind ourselves how to find that. So we start by taking a look at the 3 and the 6. The smallest common multiple of 3 and 6 is 6, because 3 times 2 gives us 6, and 6 times 1 gives us 6. So that takes care of our numbers. We also need the x, and we need x plus 3 and x minus 3. That's the least common multiple of those two expressions. For the first one, we would have to multiply it by 2. We would have to multiply that first expression by 2, x minus 3, and then that would give us the 6x, x plus 3, x minus 3, so it would give us everything we have down here. For the second one, you would have to multiply it by x times x plus 3, because then we'd have 6x, x plus 3, x minus 3, just like we have down here. So we can see they are definitely multiples of each other. For number 2, we want to start by factoring, get it down to its factors so we can see what factors they have in common and actually find the least common multiple. So for this first one, I'm going to factor out the 5 and make it 5 times x squared minus 9. And then we'll have x plus 3, x minus 3. Since it was difference of squares, there was 2 terms separated by subtraction, and x squared and 9 are both perfect squares. For the second one, you have to factor out the 4. So when you factor out 4, you've got x squared plus 6x plus 9. And so then when it factors, you'll have x plus 3 times x plus 3. Because that'll multiply out to give you the x squared, the 3x and 3x combined for the 6x, and the 3 times 3 is 9. So once again, factoring is coming back, and you've got to be really good at it. Okay, so the least common multiple. Well, if we start with the numbers, the smallest common multiple of 5 and 4 is 20. It's their product. So that takes care of the numbers. They both have an x plus 3. We need a second x plus 3 for this one. And we need an x minus 3. So every factor has to be present in the least common multiple. This first one we would have to multiply by 4x plus 3 to get what we have down here. For the second one we would have to multiply by 5x minus 3 to get what we have down here. Okay, so for number 3, again, factor. So you're going to take out your greatest common factor for this first one is 4, and you end up with 4 times x squared minus 4. And you have x plus 2x minus 2. Factor out your GCF for the second one, you'll have 6 times x squared minus 4x plus 4. So that factors into x minus 2x minus 2. So the least common multiple of 4 and 6 is 12. Because 4 times 3 is 12 and 6 times 2 is 12. They both have an x minus 2. And I need a second x minus 2 for the second expression. And I need an x plus 2 for the first expression. So there's our least common multiple. For the first expression, you would have to multiply by 3x minus 2 in order to get what you have down here, because 4 times 3 would be 12. Then we have x minus 2 times x minus 2 times x plus 2. For the second one, you would have to multiply by 2x plus 2 to get what we have down here. 6 times 2 would be 12, and then you'd have the x minus 2x plus 2. So when you're looking for a common denominator, you need to factor the current denominator. Then look at your two denominators, find all their common factors, put those down first, and then any extra factors they have to be added to it as well. You've got to represent all your factors in your least common multiple. Okay, so they start us out kind of easy with the examples. 3x over 2x plus 5 plus 1 over 2x plus 5. They already have a common denominator, so we just combine the numerators into a single fraction. We can't actually add them since they're not like terms, so we just say 3x plus 1 divided by 2x plus 5. The second one, we've got to do some factoring and find a common denominator. So if I factor that denominator, its GCF is 3x. So we have 3x times x plus 1. Okay, well I could turn a 3x into a 9x squared by multiplying by a 3x. And then for the 9x squared, I need the x plus 1. Because their least common multiple for those denominators will be 9x squared times x plus 1. So I'm going to take this first fraction times x plus 1 over x plus 1. Move this over here. Then I'm going to take this second fraction times 3x over 3x. So that my first fraction, I have to use the distributive property in the numerator and get 7x plus 7 over 9x squared times x plus 1. For my second one, x times 3x gives me 3x squared. And in the denominator, 3x times 3x is 9x squared times the x plus 1. So that now I have a common denominator. They're both 9x squared, x plus 1. So I combine the numerators, and I'll have 3x squared plus 7x plus 7 all over 9x squared times x plus 1. You think about factoring this numerator, because if it could be factored, we should do it to make sure there's nothing we can simplify out. But our product would be 21 and our sum would be 7. The only way to multiply to 21 is 1 and 21, which would add to 22, or 3 and 7, which would add to 10. So it's just not possible to multiply to 21 and add to 7. So therefore, this is as simplified as we can get. Same idea on number 3. So we're going to factor the second denominator. We're going to factor out the GCF, which is 5x. And we'll be left with x minus 2. Okay, well, to turn a 5x into a 10x squared, that's possible. So our least common multiple is going to be the 10x squared, because 10 is a multiple of the 5, and x squared is a multiple of the x. And we also need the x minus 2. So my second fraction has to be multiplied by 2x over 2x. So that 5 times 2 is 10, x times x is x squared, and then we have our x minus 2. And whatever you do in the denominator, you have to do in the numerator as well to keep it balanced, so that we're not actually changing the value of the fraction, just the way it's written. Because remember, multiplying by this is really just multiplying by 1. The first fraction has the 10x squared, but is missing the x minus 2, so we have to multiply it by x minus 2. So again, distributive property here, and so we get 3x minus 6 over 10x squared times x minus 2. Second fraction, multiply your numerators. 2x times 2x is 4x squared. In the denominator, 5 times 2 is 10, x times x is x squared, and then you have the x minus 2. And you want to keep it factored so that later, if we can factor the numerator, you can easily see if you're able to reduce anything. So now that we have the same denominator, you rewrite it as a single fraction. So the numerator combines to be 4x squared plus 3x minus 6 over that factored denominator, 10x squared times x minus 2. So again, you're checking to see if you can factor and simplify. Your product would be negative 24, and you've got to add to 3. Well, to multiply to 24, we could do 24 and 1. We need negative 24, so one of them would have to be negative. So we could either get positive 23 or negative 23. That doesn't work, so we could do 2 and 12, but if we make one of those negative, you'd either get 10 or negative 10. You could do 4 and 6, but they're going to give you 2 or negative 2. 3 and 8, but that's going to give you 5 or negative 5. So we just don't have any way to factor the numerator, so we're done. Okay, so we have subtraction this time, but it's the same process. We're going to factor the denominators. So for the first one, factor out the GCF of 2. For the second one, it's a trinomial. So you're going to reverse FOIL it. You know, you need x times x to get x squared. You're going to multiply to 3. Well, 3 and 1 are your only whole number options. And you want to add to negative 4, so you want both of these to be negative. So that you get x squared minus 1x minus 3x gives you the negative 4x. Negative 3 times negative 1 gives you positive 3. So your least common multiple then for these fractions, well, we need the 2, we need the x minus 1 that they both have, and we also need the x minus 3. So this first fraction is missing the x minus 3, so you're going to multiply top and bottom by x minus 3. The second fraction is only missing the 2, so you're going to multiply top and bottom by 2. Okay, so here you've got a binomial times a binomial, so you have to FOIL it or use a generic rectangle. So you'll get x squared plus 2x minus 3x minus 6 over your denominator, and again, keep your denominator factored so that later, if we are able to factor the numerator, we can see if we can simplify it all. For the second one, use the distributive property, so we get negative 4x minus 2. Again, keep your denominator factored. So I'm going to simplify the first fraction and combine those like terms. So we have x squared minus x minus 6 minus the negative 4x minus 2. Okay, so now if we combine the numerators, we've got x squared minus x minus negative 4x becomes minus x plus 4x, which gives you 3x. Negative 6 take away negative 2 gives you negative 6 plus 2, which is negative 4. And move everything up a little so I can fit my denominator. I was now able to go ahead and do the subtraction because I had that common denominator, so I just combine like terms. And we can factor the top. We can factor it into x plus 4 times x minus 1, because that would give us x squared minus 1x plus 4x would combine to give you 3x, and 4 times negative 1 gives you the negative 4. So there's your denominator, and we see we can divide out an x minus 1. Common factor divides out from top to bottom, and so we're left with x plus 4 in the numerator over 2 times x minus 3. And that would be your final simplified answer. Okay, so 2 more subtraction examples. Again, same process. Factor out the GCF. And factor both denominators. So for the first one, the GCF was 3. You take it out and you're left with x minus 5. For the second one, it was a trinomial, so you reverse FOIL. You know you need x times x. You're going to multiply to negative 5. The only way to do that with whole values is 5 times 1, and you have to make one of them negative. Since the 4 came out negative, you want the bigger one negative here. So looks like our least common multiple then. Move this down a little so I can write above it. Least common multiple, we need the 3, we need the x minus 5, and we need the x plus 1. So that's what our denominator is going to end up being. This first fraction is missing the x plus 1. So you're going to multiply top and bottom by x plus 1. The second fraction is missing the 3, so you're going to multiply top and bottom by 3. So here we have distributive property. X times x gives us x squared, x times 1 gives us x. Again, keep your denominator factored, so 3 times x minus 5 times x plus 1. Minus distributive property here as well. 3 times 2x gives us 6x. 3 times 2 is 6. Over your factored denominator. Now that the denominators are the same, we can go ahead and combine the numerators. So we have x squared. X take away 6x gives us negative 5x. And take away the 6. So we gotta check the numerator to see if we can factor. We can factor it into x minus 6 times x plus 1. Because x times x is x squared, x times 1 gives us 1x, negative 6 times x, negative 6x, 1x take away 6x gives us the negative 5x, negative 6 times 1 gives you the negative 6. So now we have a common factor we can divide out from top to bottom. And so we're left with x minus 6 over 3 times x minus 5. So remember, you can only divide things out that are part of products, so because we factored this, we were able to divide this away. We can't do anything else because we don't have any common factors. X minus 6 is one whole unit, x minus 5 is one whole unit, and then we have 3. So why don't you pause the video, try this final example and then come back and see how you did. Be sure to factor your denominators, find your least common multiple, multiply each fraction by what is its denominator is missing from the least common multiple, combine your numerators, and then see if you can factor and simplify. So how did it go? If you factor the denominator of the first one, the GCF was 3, so you take out the 3, and you have 3 times x minus 2. The second one was a trinomial, so you had to reverse FOIL. You know you needed x times x to get x squared. This multiplies to negative 2x, plus 4x gives us positive 2x. 4 times the negative 2 gives you the negative 8. So once everything's factored, then we can see what our least common multiple is. So you needed the 3. They both had an x minus 2, so you need one of those, and then this one had an x plus 4 you needed. So this first denominator was missing the x plus 4, so you multiply top and bottom by that. This one was missing the 3, so you multiply top and bottom by that. Here it's distributive property, so you get 2x squared plus 8x. Distributive property here as well, 15x plus 3. Now that your denominators are the same, you go ahead and combine, remembering that it's subtraction. So you've got 2x squared, 8x, take away 15x is negative 7x, and then take away the 3 gives you negative 3. It's enticing, this numerator, you think maybe you can factor, but you've got a product of negative 6x squared, a sum of negative 7x. There's just no way to get there. 6 and 1 would work if it were positive 6. But it's not, it's negative 6, so you'd have to do a positive and a negative. So we can't do it. You can't factor the numerator, so that's as simplified as you can get. 2x squared minus 7x minus 3 divided by 3 times x plus 4 times x minus 2. Hopefully you're getting the concept. You have to make sure your denominators are factored, find their least common multiple, make sure every factor is represented in that least common multiple, multiply each fraction by whatever they're missing, and then combine your numerators. See if you can factor and solve. Several steps, you just have to practice and get them down.